In this video, I'll show you an example for how to write a differential equation. So imagine you have a pool that has too much chlorine in it, let's say 4 parts per million. The recommended concentration of chlorine in a swimming pool is between 1 and 3 parts per million. So you need to reduce the chlorine levels, but you don't want to change the water level in the pool to do this. So what do? You start dumping some water out of the pool while simultaneously pouring new fresh water into the pool. A few more details. Let's say that the pool holds 25,000 liters of water, and that's pretty typical for a standard size above ground pool. That means you'd have 25 million milliliters of liquid in the pool. And since 4 parts per million are chlorine, that means you would have 100 milliliters of chlorine in the pool. And let's say that you have 2 hoses hooked up that pump water at a rate of 10 liters per minute. One hose is pumping out the overchlorinated pool water, and the other is pumping in fresh water. So this means that at any point in time, you're pumping out 10 out of 25,000% of the liquid in the pool each minute. And let's just rewrite this to make the percentage look a little nicer. So you're losing 0.04% of the pool water per minute. And let's assume that the water in the pool is always pretty well mixed. So this also means that you're going to lose 0.04% of the chlorine in the pool per minute. This is going to lead us to a differential equation because you're continuously losing a percentage of the chlorine, but the actual amount of chlorine is constantly decreasing. So you're losing a percentage of a smaller amount as time goes on. So if we define a function c of t to be the amount of chlorine in milliliters at time t in minutes, well, we started with 100 milliliters of chlorine, and that tells us that c of 0 is 100. And the relationship where we lose chlorine at a rate of 0.04% of the amount of chlorine per minute gives us the following: that the rate of change of the amount of chlorine with respect to time is negative 0.04% times the amount of chlorine. It's negative because the amount of chlorine is decreasing. So, how long should we be running these hoses to get the chlorine level down to an acceptable level? Well, that's in the next video.